Hi everyone, welcome to the 11th session of Introduction to Big Data series. In this part, we will try to understand what the Hadoop ecosystem is. If you're new and exploring my sessions and channel, then do click the bell icon below and subscribe to my channel so that you get notified about my latest videos. Hadoop ecosystem is a platform or a framework of services for Hadoop. Just for the sake of understanding, consider the Hadoop ecosystem to be a bundle of software that helps to work on big data. Hadoop 1.x had three major components in the ecosystem, which were HDFS, the Hadoop Distributed File System, MapReduce, and the Hadoop Common. HDFS is a component for storing the big data. MapReduce is the component which helps to analyze the big data stored in HDFS. And Hadoop Common refers to the collection of common utilities and libraries that support other Hadoop modules to be integrated into the existing Hadoop ecosystem. What this means practically is by utilizing the Hadoop common jar file in any new service that a developer builds, he can integrate the same with Hadoop. I consider Hadoop common to be the most important component in the ecosystem that pushed Hadoop to the level of popularity it has now. Why? Because Hadoop common provided the opportunities for the developers across the world to integrate their solutions with Hadoop and thereby leading to more innovations, enhancements, and developments. In a way, it can be said that Hadoop Common is the component that embodies the true essence of open sourcing. Later, with the release of 2.x, Yarn, yet another resource negotiator, became part of the core. Now, various services which helps in ingestion, storage, and analysis are part of the ecosystem. Let's see a high-level view of the Hadoop ecosystem. For storage, there is HDFS. For deployment and resource management, there is Yarn, Mesos, Slider, etc. In data access, for batch processing, there is MapReduce. There is the script-based ETL processing engine Apache Pig. For SQL, there are Hive, Impala, etc. For NoSQL databases, there are HBase, Accumulo, Phoenix. For streaming process, there are Storm and Flink. For search capabilities, there are Solar and Lucene. For in-memory computation, there is Apache Spark. For machine learning, Mahout. And then there are a lot of other ones like Drill, Taze, Hawk, and so on. For data workflow, there is Scoop, Flume, Kafka, etc. For management, coordination, and job scheduling, there is Zookeeper, Ambari, Oozie, NiFi, Airflow, etc. For security layer, there is Apache Ranger, Nox, etc. For data lifecycle and governance, there is Falcon, Atlas, etc. I have listed only a few among the available ones from the entire Hadoop ecosystem. There are plenty more, and at times, these services or projects have multiple functionalities as well. For example, Apache Spark has the capabilities for processing the streaming data like Storm or Flink. Like Mahout, Spark has the capability for machine learning implementations using its machine learning libraries, and even SQL capabilities like Hive or Impala using Spark SQL. Now let's see how and why there is an ecosystem. As we saw, in the initial version of Hadoop, there were three major components. The processing of data was handled by MapReduce. The MapReduce engine was built using Java programming language, and the programs that were written to process the data using MapReduce were also in Java. Let's consider a scenario that we don't know Java language, or we know only SQL, Python, or some other coding language. This means if we have to work on some big data problem, then the only way is to discard whatever expertise we have, learn Java, and then start working on the big data problem. This doesn't feel right. In addition to this, as and when Hadoop started getting used, more and more requirements for enhancements came up. These things resulted in the formation and growth of the Hadoop ecosystem. Now, the question that may come is, since we are not well versed in Java, we thought of building something new. And then projects like Apache Pig came up. But then, the coding language of Pig is something new and is called Pig Latin. This again requires learning of a new language. Then what is the difference between this to Java? The difference is that the learning curve is less for Pig Latin when compared to Java. Similarly, we can also see that projects like Hive, Impala, or Apache Spark has SQL capabilities. Why are there three different things for the same functionality? And obviously, the answer is the difference in the performance and features these projects possess. So to summarize, different projects in the ecosystem came up as a result to accommodate the expertise in various coding languages and to fulfill the various use case requirements that came up as part of Hadoop implementation. Different projects with same functionality exist in the ecosystem due to the difference in the performance and features that they have. With that, we come to the end of this session as well. If the video was informational, please do like, comment and share the video, and do support me by subscribing to my channel.